There is a $3 piece of black polyethylene pipe at any hardware store. It heats water to over 140 degrees using nothing but sunlight and delivers a full hot shower without electricity, without gas, and without a monthly bill. A licensed plumber charges between $1,200 and $3,500 to install or replace a conventional water heater, and the energy to run that heater costs the average American household $400 to $600 every single year for the rest of their lives. The energy industry buried this pipe. They buried it because it cannot be metered, it cannot be billed, and it eliminates the single largest recurring energy expense in every home in America. The emergence of solar heating industries alarmed oil corporations and utilities, and several of these companies embarked on a concerted public misinformation campaign designed to downplay the potential of solar energy, undermining the development of nascent solar industries. The financial motive was not complex. A customer who heats water for free is a customer who stops paying. This is the story of the black polyethylene pipe solar heater that the energy industry prayed you would never find. Welcome to Forbidden Camping. If these stories matter to you, hit subscribe and the bell. This is where we dig up what the industry buried. Now let me take you back to where this formula was born. The year was 1891. In 1881, Clarence Kemp founded the C.M. Kemp Manufacturing Company in Baltimore to manufacture many products of his own design, including valves, motors, and equipment for utilizing acetylene. In 1891, Kemp patented a commercial solar water heater that he called the Climax system. During this time, many people secured hot bath water using a wet-back wood stove or range in which water was heated via a coiled pipe that passed through the stove. Kemp thought it unpleasant to heat up the stove during the hot Maryland summers. Instead, his invention consisted of 3 tanks mounted in a frame under glass on the south side of the roof of a house. The tanks were filled with cold water from the water mains, heated by the sun, and then used for bathing or other purposes. By enclosing the tanks in the frame, Kemp ensured the tanks were somewhat insulated and did not lose heat to the wind. The principle was stunningly simple. Dark surfaces absorb solar radiation. Water inside those dark surfaces absorbs and retains that heat. Glass over the top traps it, creating a greenhouse effect. No moving parts, no fuel, no wiring, just physics that had been understood since the 1760s, when Swiss scientist Horace Benedict de Saussure first demonstrated that in 1767 he built an insulated box, its bottom painted black to absorb as much sun energy as possible, with 2 panes of glass covering the top. De Saussure found that when he exposed the box perpendicular to the sun, the inside heated to temperatures far above the boiling point of water. The Swiss scientist had demonstrated for the first time the greenhouse effect. Kemp turned that 130-year-old science into a commercial product that worked. It really took off in Southern California, where fuel was especially expensive and there was a lot of sunshine. By 1897, a third of the residences in Pasadena heated their water with Kemp's devices. 1/3. Not a fringe experiment, not a handful of eccentrics. 1 in 3 homes, running hot water from the sun without a single utility payment. In 1909, William J. Bailey found a way to improve the design by separating the solar heating of the water from its storage. His solar collector consisted of water pipes attached to a black painted metal plate inside a glass-covered box and connected to an insulated remote storage tank located above the collector. As the sun heated the water, it became lighter than the heavier, cooler water entering from the bottom, forcing the hotter water to naturally rise into the storage tank and remain warm during the night and the following morning. Bailey called his company the Day and Night Solar Water Heater Company to emphasize his product's advantage. Day and night solar water heaters soon drove the Climax out of business to dominate the burgeoning solar water heater business in California, Arizona, and Hawaii. By the end of World War I, over 4,000 had been sold. In 1923, Bailey sold the rights on the heater. By 1941, at least 60,000 solar heaters were installed. 60,000 homes. No gas bill, no electric bill, just the sun. Then the suppression began. The discovery of plentiful oil and natural gas in Southern California in the 1920s killed the local solar water heater business. The reason for the demise of solar water heating systems in California during the 1920s and in Florida in the 1950s was simple economics. After the introduction of cheap natural gas and electric power, the cost of heating water dropped precipitously, making solar water heaters non-competitive. From the 1950s to the 70s, America experienced the rise of cheap energy to levels unknown in history. The gas companies did not build a better product. They built a cheaper, short-term illusion that locked every household into permanent monthly billing. When the war came, the government froze the use of copper, bringing the solar industry to an abrupt halt. After the war, the utilities never let it recover. The 1950s brought subsidized gas lines into every new subdivision. The 1960s brought electric water heaters marketed as modern and automatic. By 1970, solar water heating in America was functionally extinct. Not because it failed, because it worked too well and generated zero recurring revenue. Then came 1973. The oil embargo of 1973 was a significant turning point in the history of solar energy. The effect of rising prices and shortages of oil and natural gas began to sensitize the American public to the fact that our honeymoon with cheap energy was over. By the late 1970s, America's energy situation had become critical. President Jimmy Carter spoke on June 20th, 1979, at the dedication ceremony for the 32 solar panels he had installed on the roof of the White House. The installation of the solar panels reflected the energy goal of his administration to achieve 20% renewable energy by 2000. Solar water heating surged back. Homeowners built simple coil systems from black polyethylene irrigation pipe for a few dollars and ran hot water off the sun again, just as their grandparents had. The industry panicked. Ronald Reagan broke sharply with Jimmy Carter over energy policy. He considered solar energy a fanciful and unpromising technology. Reagan rejected Carter's message to the American people about energy scarcity and conservation. Where Carter asked Americans to make do with less by living thriftily, Reagan promised a future of energy abundance supplied by fossil fuels. After Reagan's election in 1980, the new administration emphasized the development of domestic oil, gas, and nuclear power, and allowed the solar energy tax credits to expire while slashing funding for solar research and development. Reagan dismissed Dennis Hayes and hundreds of employees of the Solar Energy Research Institute. Reagan's administration reduced solar funding, redirected and reorganized solar agencies, and repressed solar information. By the early 1980s, Carter's 20% solar goal was dead, and as a result, the nation's efforts toward developing solar energy were set back decades. The $3 pipe disappeared from public conversation, not because the physics changed, because the policy changed. And the policy changed because the money demanded it. Now, before I continue, I need to stop and tell you something important. Everything I just described, the buried methods, the suppressed solutions, the knowledge that your grandparents used, and the industry erased, that is exactly what the Forbidden Camping Vault was built to preserve. Inside the vault right now, you will find the following: a guide to building a full gravity-fed solar shower system using black polyethylene pipe for under $8 in total materials. A step-by-step method for waterproofing any fabric permanently using paraffin wax and mineral spirits, the same formula the military used before they switched to fluorocarbon sprays that wear off in 3 washes. A detailed walkthrough of the calcium carbide lamp, the $2 lighting system that miners used for decades before battery companies buried it. A report on the pine resin and beeswax wood sealant that outperformed every polyurethane in independent testing and costs 40 cents per application. A blueprint for the clay pot evaporative cooler, a zero electricity refrigeration method dating back to 2500 BC that keeps food below 40 degrees in ambient heat, a full restoration protocol for cast iron cookware using flaxseed oil polymerization, the chemistry behind the non-stick surface that the Teflon industry spent billions trying to make you forget. A complete field guide to the saltwater battery, a method of generating emergency DC power from materials found in any kitchen. Over 10 guides in one place. No filler, straight to the point. The link is in the description right below this video. But stay right here, because the science behind this is about to change how you see everything. Here's why a $3 piece of black polyethylene pipe heats water so effectively that the entire utility industry had to bury it. The physics operates on three converging principles: solar absorption, thermal mass transfer, and the greenhouse retention effect. Black polyethylene absorbs approximately 95% of incident solar radiation across the visible and near-infrared spectrum. This is not an estimate. This is a measured value documented in materials science literature and confirmed in applied testing. Research by Iranian and Kuwaiti scientists in Tehran confirmed that black polypropylene had good heat transfer properties and would be suitable for solar hot water systems, as published in An Experimental Evaluation of Copper, Steel, and Polypropylene Tubes in Solar Water Heaters with Thermosiphonic Flow by M.R. Riazi, J. Razavi, A. Sadeghi, and A. Javaheri in Applied Solar Energy, Volume 45, Number 1, March 2009. The study demonstrated that simple plastic tube collectors achieved thermal performance within a usable range of copper-based systems at a fraction of the material cost. When sunlight strikes the black surface of polyethylene pipe, photon energy converts to thermal energy at the molecular level. The polymer chains in the pipe wall vibrate at higher frequencies, transferring kinetic energy to the water molecules inside through direct conduction. Water has one of the highest specific heat capacities of any common substance, 4.186 joules per gram per degree Celsius. That means it absorbs an enormous amount of heat energy before its temperature rises, and then it holds that energy for a long time. In practical terms, 100 feet of 3/4-inch black polyethylene pipe holds approximately 2.9 gallons of water. Exposed to direct sunlight in an insulated enclosure, that water reaches between 130 and 150 degrees Fahrenheit within 2 to 4 hours depending on latitude and season. Systems using 80 feet of 1/4-inch black polytube, rated up to 180 degrees Fahrenheit, have achieved temperatures up to 145 degrees Fahrenheit, with higher water temperatures achievable with additional tubing or higher air temperatures. Performance testing on PEX-based solar systems has shown a 40-degree Fahrenheit temperature rise within the box after 2 early morning hours of direct sunlight. The efficiency of solar thermal collectors can be as high as 87%, meaning very little solar energy is lost in the process. Solar hot water systems in California reduce fuel usage for water heating, usually natural gas, by 75% or more in the buildings that employ them. That is not a marginal improvement. That is the near total elimination of a utility expense, and that is the problem. Commercial water heaters are not designed to last. The average tank water heater has a lifespan of 8 to 12 years. The heating element corrodes. The anode rod dissolves. The tank rusts from the inside. These are not flaws. These are features. They guarantee that every household replaces the unit and continues paying for the energy to run it. The system is not broken. It is working exactly as designed. Now let me show you the money. The global water heater market size was estimated at $30.485 billion in 2024 and is projected to reach $46.338 billion by 2033. $30 billion a year. That is the market that a $3 pipe threatens. The major players operating in the water heater market include A.O. Smith, Robert Bosch, LLC, Ariston Thermo S.p.A., Rheem Manufacturing Company, Rinnai Corporation, Bradford White Corporation, Noritz Corporation, Whirlpool Corporation, Westinghouse Electric Corporation, and others. Companies like A.O. Smith, Rheem, and Bradford White dominate the North American residential water heater market. The U.S. dominated 79.6% share in the North America residential water heater market with around $2.7 billion revenue in 2024, with ongoing development in the service sector, along with the presence of major water heater manufacturers, including A.O. Smith, Bradford White, and Rheem Manufacturing. These companies do not sell you hot water once. They sell you a machine that needs replacement every decade and requires paid energy every single day it operates. The reapplication cycle is deliberate. Anode rods are engineered to deteriorate within 3 to 5 years, requiring either replacement or full unit failure. Heating elements are rated to outlast the warranty period, but fail reliably after it expires. Glass-lined tanks develop microfractures in the lining that accelerate corrosion from the inside out. Every component has a designed failure point that triggers the next purchase. You cannot build a subscription economy around a permanent fix. A coil of black polyethylene pipe does not corrode. It does not have a heating element. It does not have an anode rod. It does not require electricity or gas. It has no moving parts. It cannot be metered. It cannot be billed. And it cannot be patented, cannot be licensed, and therefore cannot generate the recurring revenue that sustains the industry. That is why it was buried. The raw material, black polyethylene irrigation tubing, is sold in every farm supply store and most hardware outlets. It is classified as agricultural supply, not plumbing. It is not marketed to homeowners. It is not displayed in the water heater aisle. It is not mentioned in any home improvement guide published by any major retailer. The distribution is technically public. The information is functionally invisible. Virtually any building with a need for hot water and a roof exposed to the sun can take advantage of solar hot water, but less than 1% of California buildings have systems installed today. Less than 1% in the sunniest state in the nation. That is not an accident. That is control. If this information is new to you, share this video with one person right now. That act alone breaks the suppression chain. And if you have not subscribed yet, do it now, because the next one goes even deeper. Here is exactly how to build the system. You need the following materials. One 100-foot coil of 3/4-inch black polyethylene irrigation tubing, available at any farm supply store or big box hardware store for $8 to $12. One sheet of 1/2-inch plywood, 4 feet by 4 feet, which costs approximately $12. One piece of rigid foam insulation board, polyisocyanurate type, 1-inch thick, 4 feet by 4 feet for approximately $9. One sheet of clear polycarbonate or an old glass window, minimum 3 feet by 3 feet, which can be salvaged for free or purchased for $15 to $20. Flat black spray paint rated for high heat, 1 can, approximately $5. 4 L brackets and wood screws for mounting, approximately $3. Standard garden hose fittings for the inlet and outlet connections, approximately $4. Total material cost for the complete system runs between $41 and $55. Begin by cutting the plywood to your desired collector size. A 4x4 foot panel is sufficient for a single-person shower supply. Lay the rigid foam insulation on top of the plywood, foil side up, and secure it with construction adhesive. This creates the insulated backing that prevents heat from escaping downward. Next, coil the black polyethylene tubing in a flat spiral on top of the insulation board, starting from the outside edge and working inward, leaving approximately 1 inch between each pass of the coil. Secure the coil to the board using pipe clamps or zip ties screwed into the plywood through the foam. Paint the entire interior surface of the coil and any exposed insulation with flat black, high-heat spray paint. Allow the paint to cure fully for 24 hours before exposing the system to sunlight. Place the glass or polycarbonate sheet over the top of the box, sealing the edges with silicone caulk or weather stripping to create an airtight greenhouse chamber. Mount the completed collector panel on a south-facing roof surface or ground frame at an angle of 30 to 45 degrees from horizontal, matched to your latitude. Connect the bottom inlet of the coil to your cold water supply using a standard garden hose adapter and a shutoff valve. Connect the top outlet to your shower head or hot water storage vessel using a food-safe hose. Open the valve and allow the panel to fill. After 2 to 4 hours of direct sun exposure, the water inside will reach between 120 and 150 degrees Fahrenheit. One critical safety warning. Water inside an enclosed black pipe solar collector can exceed 170 degrees Fahrenheit on high sun days, particularly in southern latitudes during summer months. This temperature causes severe scalding in under 1 second of skin contact. The Consumer Product Safety Commission has documented hundreds of scald injuries annually from water above 140 degrees. Always install a thermostatic mixing valve at the outlet of your system, which costs $12 to $18 at any plumbing supply outlet to blend cold water into the outflow and cap delivery temperature at a safe 120 degrees. Never direct the raw output to an unprotected shower head without temperature regulation. The total cost of this system, including the mixing valve, is between $53 and $73. A professional water heater installation, including the unit, labor, permits, and materials, costs between $1,200 and $3,500. The energy to run that conventional heater costs $400 to $600 per year. The polyethylene solar collector costs $0 per year to operate. $0. for the remaining useful life of the pipe, which under UV-protected conditions exceeds 15 to 20 years. This knowledge did not vanish because it stopped working. It vanished because it worked permanently, and permanent solutions do not generate profit. Your grandparents knew this. The generation that built the houses you live in, that wired the barns, that ran pipe by hand through clay soil, they heated water from the sun as a matter of common sense long before anyone called it solar technology. California has a long history with solar hot water. In the late 1800s, before oil and gas became available in the West, more than 1/3 of Pasadena residents had solar hot water systems. That knowledge was not lost. It was taken. It was taken by industries that understood that a self-sufficient household is a non-paying customer. Every time you learn something like this, every time you build it with your own hands and disconnect one more expense from your monthly obligation, you are reclaiming what was stolen from the generation that raised you. That is not nostalgia. That is resistance. Subscribe to this channel, and you are not building someone's audience. You are preserving a library of methods that powerful industries spent decades burning. Share this video, and you hand someone else the match to light their own path out. Hit the like button, and you push this past the algorithm that was designed to keep it invisible. This is not content. This is inheritance. The next vault opens soon, and what is inside is even heavier than what you heard today.